Today we're going to be still continuing our discussion on triangles. So we're going to call it even more on triangles. Now at the beginning of our geometry unit, we learned about some lines we could draw inside of a triangle. So the lines we learned about that we could draw inside of a triangle were the altitude, the angle bisector, the perpendicular bisector, and the median. So the altitude was when we took a triangle and we took from one vertex to the other side of the triangle, and it had to hit the other side at a 90-degree angle. Now mine looks kind of sort of like it cuts that in half, but it doesn't have to. It was just the way I drew that triangle. With an altitude, if we have an obtuse triangle and we want to draw the altitude, it's actually going to have to be drawn outside. If I start from this vertex to go straight down at a 90-degree angle, we have to kind of extend one of the sides of the triangle, and we actually consider that altitude being outside the triangle. So the second line we learned to draw was the angle bisector. The angle bisector, remember the angle is inside of the triangle. So if I look at one of my angles, angle bisector means we're going to draw a line that cuts that angle in half. So we're going to eyeball it and find the midpoint. That's about halfway along that angle. So the angle bisector would be a straight line going from the vertex of that side of the triangle through the middle of the angle. And again, it kind of looks like it cuts that other side in half, but it doesn't have to. So angle bisector, all we know is it cuts this angle in half equally. We learned how to draw the perpendicular bisector. The perpendicular bisector goes through a side halfway on the side. So if I take this side and I cut it in half, and then you have to draw your line at a 90-degree angle. So we want it to make that little square. That one didn't start from one of the vertexes, whereas all the rest started from a vertex. And then we also learned about a median. The median starts from a vertex, and it cuts the other side in half, the side across from it in half. So again, we have to eyeball it and kind of find halfway on our line. If we were using a ruler, we could measure it and make sure we were a little more closely halfway. Or if we had a compass, we could actually find exactly halfway. So I said we'd be revisiting these because when you draw a median or an altitude or an angle bisector and you do it from every single vertex, or in the case of the perpendicular bisector, you go through every single side, then they actually meet at a point, and most of those points have certain properties we're going to learn about. So we started with altitudes. If we draw in one triangle all three altitudes, they will meet at one point called the orthocenter. So the orthocenter is made using altitudes. So if I were to draw a triangle, and try and draw a triangle pretty close to that in your notes, and I were to draw in my altitudes from every single vertex. So if I were to pick this bottom right-hand vertex, it's going to hit the other side at a right angle, about there. So we hit that side at a right angle. Now we pick another vertex, and we try and hit the other side, the side across, at a right angle. And then our third vertex, we try and hit the bottom side at a right angle. They meet at one point. We call that point the orthocenter. Now, just like the altitude could actually be drawn outside of the triangle, the orthocenter may also end up being outside of the triangle. So we're going to have to draw our orthocenter twice so we can see that it's possible to draw it outside of the triangle as well. So let's start with this bottom vertex because it's easier for us to see where it hits at a 90-degree angle. This time I'm going to extend it outside of my triangle. All we know for sure is that it hits at a 90-degree angle. Well, if I'm going to draw my altitude from that vertex, that's going to happen outside of the triangle. So I'm going to have to extend aside so that I can see where it crosses at a 90-degree angle outside of the triangle. Our last one will also hit outside of the triangle, so I also have to extend the other side. And you see how it meets again. This time it meets outside of the triangle. This is also the orthocenter. These were both the orthocenters. We were just showing that it can happen inside of a triangle, or it's possible for it to happen outside of a triangle. So the orthocenter was made using the altitudes. The second one is called an incenter, and it's made using the angle bisectors. Now the the incenter is always inside the triangle. And it's the same distance away from all three sides. So we're going to take one triangle again and draw three angle bisectors and see where they intersect. So again, right now we're just eyeballing. We're just approximating where this angle bisector actually is. So we look at one of the angles and we try and cut it in half as much as possible. So we know those two sides are the same. Or sorry, those two halves of the angle are the same. We start at the vertex and go through that point. So there's one angle bisector. We take a different angle, try and find halfway on the angle. and then going from the vertex through that line, or through that point to draw your angle bisector. There's our vertex. Again, we're trying to go halfway, trying to cut that angle in half. And when we get all three angle bisectors drawn in our triangle, we see they meet, and where they meet is called the incenter. Now this incenter is special because it's the same distance away from all three sides. If we were to draw a circle inside of the triangle, that would be the center point of our circle, and where the circle touched the edges of the triangle is where our incenter is the same distance away from the outside. So I'm going to attempt to draw my circle. It is hard to draw a circle when we know it's supposed to be a certain center of the circle. So that incenter is actually the center point of a circle, where that center point is the same distance away from the three sides of the triangle. So we have two more that we can draw. We have the circumcenter and we have the centroid. Now both of these we're going to be able to do a little more math with. They have a few more special properties than these first two. These first two we need to know how to draw them, what their names are, but the last two we're going to be able to do a little more math with. So our next point of concurrency is called the circumcenter. So when I say point of concurrency, it's just where the three lines cross. And the circumcenter is made using perpendicular bisectors. This point is the same distance away from all three vertices of the triangle. So this is a point of concurrency where, again, it could be inside the triangle, it could be outside the triangle, and the one we're really going to focus on is when we have a right triangle. So let's see what the picture will look like if we have one inside the triangle, and what the picture will look like if we have one outside the triangle. And then we're going to focus on our right triangles. So this was again made using perpendicular bisectors. So again, we're kind of eyeballing it right now. And we pick a side. I'm going to pick this bottom side here, and I'm going to pick the point about halfway. Perpendicular bisectors was halfway, so we're kind of eyeballing where is halfway. And then we're going to draw a line at a right angle. It should make across a T instead of across like that. So we're trying to make it as teed up as possible. We want it to be a right angle to that side. We don't care where it hits the other side of the triangle. So now we pick a second side. Let's pick this top left side, and we're going to, again, eyeball about where halfway is. We draw at a right angle there. And then our last side, again, we pick about halfway. and draw at a right angle. So our circumcenter is this point where they cross. So we have the option of having the circumcenter inside the triangle. We also have the option of our circumcenter meeting outside the triangle. Again, we pick halfway, and we try and make a right angle as much as possible. Where we're eyeballing it, we might not get it exactly, but we'll get pretty close. Again, we don't care if it passes through the vertex or not. We don't care if it hits the corners. We're just focusing on the sides. Make halfway. Go at a 90-degree angle. And where they cross is the circumcenter. So that one was outside the triangle. But it's still the circumcenter because the circumcenter is always made using perpendicular bisectors. So our last one with the circumcenter, and the one that we'll focus on and we can do an example with, where we have to find some information using math about this and not just identify the picture, is what if we have a right triangle? So for our triangle to be a right triangle, again, we're going to try and make that as much of a right angle as possible. 90 degrees should look like it's forming the corner of a square or a rectangle. So again, we do our perpendicular bisectors. Perpendicular means it's at a 90-degree angle. Bisector means it's halfway. So we go halfway, draw our 90-degree angle, and draw a straight line. Or mostly straight line. Halfway, 90-degree angle, draw a straight line. Halfway, 90-degree angle, draw a straight line. So what's special about the right triangle is that the circumcenter is on the hypotenuse. And it's not just on the hypotenuse at any point, it is exactly halfway on the hypotenuse. So the circumcenter is the midpoint of the hypotenuse of a right triangle. So if it's a midpoint, these two sides are the same. So now we're going to do our first example. A lot of the assignment will be identifying, is this picture an altitude, or is this picture an orthocenter, or is this picture an incenter? So you'll definitely want to make sure you have your notes with you for the assignment, because you're probably going to have to refer back to the pictures quite often. You're not going to get these memorized after seeing it once. You're going to have to practice with them. So what I'm going to ask you to do with this circumcenter, only when it's a right triangle, is I'm going to have you actually find the coordinates. We're going to put our triangle on a coordinate plane. So find the coordinates. Of the circumcenter. Now we can find the coordinates of the circumcenter for any triangle, but it's a lot more difficult if it's not a right triangle. So if we're going to find the coordinates, we need a coordinate plane. So I'm going to draw my coordinate plane. I did make it skewed on purpose. I didn't put the center in the middle because we're going to just utilize this right side mostly. And then I'm going to put one of the vertices here, one of the vertices here, and one of the vertices here. So we know that the circumcenter is located on the midpoint of the hypotenuse. So it's about here. That's us eyeballing it. But what if I want to find it exactly? I don't want to just eyeball it. Well, if I want to find the midpoint of the hypotenuse, I'm going to be focusing solely on this line. We know that's the hypotenuse because it's across from the right angle. It's like that right angle is pointing at the hypotenuse. So if I'm going to find the midpoint, I need to know what are the coordinates at the ends of the hypotenuse. So this first coordinate on the bottom left, x value is 1, y value is 0. We went right 1, but we didn't go up or down at all. The coordinate on my other end of my hypotenuse is 1, 2, 3, 4, comma, 1, 2, 3. I was meaning for that to end up at 3. It's a little harder since we don't have an entire grid. But I was wanting that to end up at 4, 3. There will be a grid on the assignment, so that won't be a problem on the assignment. So if we're going to find the midpoint is just the average of the x values and the average of the y values. So the midpoint is the two x values added together, divided by 2, and the two y values added together, divided by 2. So looking at our coordinates, here's an x value, here's a y value, but this also has an x and a y value. So I just have to say, well, this is x from the first point. That's why we would put x1. This is y from the first point. This is x from the second point. This is y from the second point. So now I add my x values together. x1 was 1 plus x2 is 4 divided by 2. y1 is 0, y2 is 3. So we add these together, we get 5. We add first, oops, 5 divided by 2, that 2 should not have changed at all. 0 plus 3 is 3. And now divide, we are going to end up with some decimals. 5 divided by 2 is 2.5. 3 divided by 2 is 1.5. So this coordinate, that is our midpoint, is exactly at 2.5, comma 1.5. We can actually find the circumcenter as a coordinate if we have a right triangle. Okay, so our last point of our concurrency, our last thing is when the medians meet. So we also need to know what it's called when the medians meet. And that's called the centroid. The centroid is made using the medians. It's always inside and it actually has a very good use in physics. The centroid is the center of mass. If we were to draw a triangle and cut it out, the centroid would be the point where you could actually balance that triangle on like a pencil. So it's kind of its balance point. So if we're using medians, the median went from a vertex to the midpoint of the opposite side. So there's our first median, vertex to the midpoint of the opposite side. Second median, vertex to midpoint of the third side. So that meets at a point called the centroid. about the centroid is, again, if I put this on a coordinate plane, I could find the coordinate of the centroid. And it also cuts each of the medians into a certain length. It cuts this into a ratio of 2 to 1. That means from here to the centroid is twice as long as the centroid through to the rest of the median. So we have just 2 more examples. Say we want to find the coordinates of the centroid. So I'm going to put one vertex at the point -2, 1, one at the point 3, 2, and one at the point 1, 4. So this is the point -2, 1, this is the point 3, 2, and this is the point 1, 5. Finding the coordinate of the centroid is very similar to finding the coordinate of the circumcenter. Except instead of being the average of, the average of the 2 ends of the hypotenuse, it's the average of all 3 vertices. So if we're going to average all 3 vertices, we're going to have to add all 3 x values. And if we're averaging it, since we added 3 things together, we divide by 3. That should be a y value, not an x value, sorry. So we add all 3 y values together, divide by 3. That will give me the coordinate of the centroid. So x values, that's the first number in each parentheses. So we have -2, +1, and +3. Here are our x values. And we're going to divide by 3. Y values, we have +1, +5, +2. I just realized I need one more. Actually, that would not be the good place to put it. That's going to be 5. I should have had one more tick mark there. So now we just add and divide. -2 + 1 + 3 is +2. 1 + 5 + 2 is +8. We could leave it as a fraction, or we could make it a decimal. We would have 0.6 and 2.6. Now I did plan one more example, but I think we're going to have to do it in class because this video is getting a little bit longer than I wanted. So I will stop here and we'll do one more example in class when I see you on Thursday. And by the way, hey Dalton.